This is geometry. We're working on proving triangles congruent by side, side, side. We talked about if we have three sides congruent to three sides. All right, we have a pair of yellow sides, a pair of green sides, and a pair of purple sides. If we connect and make a triangle out of the first three sides in any order you want, and you come over and use those same side lengths, but make a triangle in any order that you want, those two triangles are guaranteed to be the same size and shape. By flipping it over, you can see that they have the same lengths, they have the same angles. So just by knowing the sides, I know these two triangles are congruent. I did not make the triangles with angles, I only made them with sides. So we can prove triangles congruent using this postulate called side, side, side. If three sides of one triangle are congruent to three sides of a second triangle, then I know the two triangles are congruent by side, side, side congruence. So for two triangles to be congruent, that tells us that the corresponding angles are congruent and the corresponding sides. We do not need to know anything about the angles. The angles are automatic. If the sides are going to match, the angles will match. Something we're going to talk about is the reflexive property. The reflexive property is when you share the same segment in two different pictures. When you share the same segment, or it can even be an angle, segment or an angle, share the same segment in two figures. That is the reflexive property. So for example, we can come down here and we'll call this that middle segment, and we'll say that both of these triangles have a yellow side. That's going to be the 9. Both triangles have a yellow side. Both triangles have what looks like this purple side. So I know that one triangle has a yellow, as does the other triangle. One triangle has the purple, so does the other triangle. But I only have a green side left. I don't have two green sides. I thought I needed 6 sides to make two triangles. I have a pair of yellows, a pair of purples, but I only have one green. This green is being shared by both triangles. So the green in this triangle to the left is the same as the green in the triangle to the right. We call that the reflexive property. So by looking down here at this picture, we know that this LK is going to be congruent in both pictures. LK is congruent to LK by reflexive POC. We know that those two segments have to be the same. So now they both have a 9, they both have an 8, and they both share the same side. So I know that JL is congruent to ML, because that was the given. I know that JK is congruent to MK, because that was also part of the given. It's in the picture. The numbers are the same. Therefore, triangle JKL is congruent to triangle MKL by side-side-side congruence. We know the two triangles are congruent because we have three sides of one triangle congruent to three sides of a second triangle. Next, we're going to look at this figure over here. Are those two triangles congruent? And we can look at it, and we can say, okay, let's try to decide this out. Say, look at me. I have a 2 ticker. We'll call it this purple size. And it goes with the 2 ticker, which is this purple color. Then we'll say that the 3 ticker, we'll call that this green side. That's going to match down here with this purple one. Okay, just like that. And I have to have a 3 ticker in this triangle, which is over here. So far, it's looking okay, right? They both have a green. They both have a purple. So the triangles probably have to be congruent. Now, what gets kind of weird is that I can still have the green. I can still have the purple. I didn't change that at all. But my third side might be blue. Or we can call that purple if you want. Or I could come over here and still have this side that matches, this side that matches, but not use this length, which maybe we call it blue. It's blue to my eyes. So we have a purple for both of them, a green for both of them, but just because you have 2 sides that match, the third side doesn't have to match. They're not sharing the same side. This is not reflexive property. So there's not enough information. If you look at the 2 triangles, they're different. We have a green, purple, and orange. We have a green, purple, and blue. We do not know if RS is congruent to TV. We don't know that. So, not congruent. So, triangles, not congruent. So now we're going to come down and try to write out some proofs. To do these proofs, it may be helpful for you to look at your yellow sheet. There are some wordings for proofs that could be very helpful in here. The back side has a few others. One that we're going to look at today, if segment bisected, then the segment is divided into 2 congruent segments. There's a shortcut we can say, if bisector, then two congruent segments. That would be like as short as we could call it. But that's one we're going to use today. So let's take a look at this. First, we got to make our plan. We got to look at our given information. We know that Wx is congruent to Yx. We know that Z is the midpoint of YW or WY. Z is the midpoint. Remember, it's bisected, or the word would be midpoint. They don't use the word midpoint on here, but if midpoint, then this segment is divided into two congruent segments. So if we have a midpoint, if it's bisected right down the center, which is what a midpoint does, then we have two segments that are congruent. So I know one set of sides are the same. I know another set of sides are the same. I'm looking for a third set of sides to be the same, because that's the way you prove triangles congruent. So in my plan, I need to come up with now another step. Does anyone recognize what we need to know by looking at this picture, even before we start our proof? We've got our given. We have our two segments that are the same. We've got our midpoint that produces two segments the same.
X and Z share the same. They're both parallel to the
We have this shared side in both triangles. It's going to be the same. We call that the reflexive property. So in our proof, we say that Wx is congruent to Yx. We also say that Z is the midpoint of Wy. That is our given information. And we drew that on our picture already. What does the midpoint tell us? What were we able to say because of the midpoint? We knew something. It wasn't exactly what the given told us. It was all about that midpoint. The midpoint told us that we had Wz congruent to Yz. If midpoint, then two congruent segments. So far, we've got a pair of sides congruent. We have another pair of sides congruent. Now I'm looking for a third item that must be congruent. We need to talk about our xz is congruent to our xz. We've got to get all three bits into our proof. And they were congruent because of the reflexive POC, property of congruence. Reflexive property of congruence. Now that I've got a pair of sides congruent, another pair of sides congruent, a third pair of sides congruent, I know that triangle WXZ is congruent to triangle YXZ. And the only method we've learned so far is side, side, side congruence, SSS congruence. The S's stand for sides. So you proved those two triangles would have to be congruent. Let's look at here this last one. You got to make a plan. Work on this before. Decide how it works. Use your own words in your head. But if you know that IJ is congruent to HK and HI is congruent to JK. That's the given information. That's only two sets of sides that match. I need to come up with a third set of sides that match. I don't have any midpoints, so I can't use that. But I do have this side that's being shared. So the side that's being shared, of course, is in both triangles. That's the reflexive property. So now I have a 1 ticker in both, a 2 ticker in both, and a 3 ticker in both. So our number 1 is our given. IJ is congruent to HK, and IH is congruent to JK. That is our given. The second thing we noticed is that JH, now let's read this carefully. JH in this triangle came from the 1 tick mark down to the 2 tick mark, so we called it JH. The second triangle, the 1 tick mark is down here, the H, up to the J. So we're going to change the order and call this HJ because the triangles are not reflected. They're actually rotated. And we know that those two are congruent by the reflexive property of congruence. Now I have 3 sides of one triangle congruent to 3 sides of another. So my triangle HIJ is congruent to triangle JKH. And that's a side-side-side congruence. You only use the SSS with congruent triangles. SSS is part of your yellow sheet. SSS congruence.